Hi, I'm Melissa, and today we're going to tweak the Arduino logo using serial communication and a programming environment called processing. We usually connect different devices to each other using different communication protocols. For example, we connect our mobile phones to headphones using Bluetooth, and our mobile phones and computers to the internet using Wi-Fi. In a similar way, the communication between the board and the computer is through serial communication. The information the microcontrollers work with is data in binary code. This code is built only with 0 and 1. When the board sends or receives data to the computer, the data is in binary format. In this project, we're going to control a processing sketch with the Arduino via serial communication. Processing is free open source software based on Java. It is designed for the visual arts community for creating drawings, animations, and interactive programs. Download the latest version of Processing from processing.org. Select the right choice according to your operating system. Processing is available for Linux, Mac, and Windows. Extract all the files and click the processing icon inside the folder to open it. Before we start to use this new programming environment, we need to build our circuit. In this project, you only need to connect one component, which is the potentiometer. You can connect wires for power and ground here, like we done in the previous projects. Or since we are only using one component, you can also connect the wires from the row with the potentiometer's legs directly to power and ground. Connect the middle pin of the potentiometer to analog pin 0. And then connect your board to the computer. First, open the Arduino IDE and upload the example sketch for Project 14. This sketch is as simple as the circuit. In the setup, we initialize serial communication. And in the loop, we use serial write command to send that information over the serial communication. Analog pins can read and send values between 0 and 1023. However, the serial write command can only send values between 0 and 255. Meaning that we need to divide the value we read from our potentiometer by 4. After you have uploaded the code from Arduino IDE to your board, you can take a look at the processing text editor. It looks similar to the Arduino IDE, but the languages have some differences. To learn more about processing, you can visit processing.org/tutorials and look for Getting Started guide. You can either write the sketch following the example in the projects book, starting from page 149, or copy the example code from your Arduino IDE on the bottom of the sketch for Project 14. Let's take a look at the example sketch. First, we need to import the serial library and create an instance of the serial object. We also need to create an object for the logo and a variable for the background color of the logo. By turning the potentiometer, we're going to change this color. First, we give commands for the processing output window. The size, allow it to be resizable, and set the color mode. In this URL, you can find an Arduino logo with a transparent background. This is the logo we're going to use in our program, but you could also decide to use some other image and its URL. As well as we set the size of the window to be the same size as the image. Here we give information about the serial communication, which application it will be speaking to, which serial port it will communicate over, and at what speed. After the loop, we have a draw function. Inside this function, we read the value from Arduino and use that as the background color. Then we set the color of the window using the comment background and draw the logo on the window using the comment image, starting from the coordinates that correspond to the ordered pair. Now we can test the project. Click the Run button and a window with the Arduino logo should open. To change the background color, turn your potentiometer. Now that you have your first processing program working, you can explore the tutorials on their site and create digital art using different colors, shapes, and images. In the next project, we will learn how to